So in this example, we're given a simple voltage divider circuit, and we're given some of the values. So we know that R1 is equal to 47 kiloohms. We also see that the supply voltage is equal to 200 volts. And so now they're asking us to determine what value of R2 do we need to put in this circuit so that our output voltage here will be 22 volts. And then once we determine what that resistor is, they want to know if we have a resistor rated for that ohms that's rated for a quarter watt. Would that resistor work there, or would the wattage be too high? So to do this, we need to recall the equation for a voltage divider circuit, and so that can be written as the ratio of the output voltage to the supply voltage. And again, this is just a standard equation. It's R2 over R1 plus R2. And so in this case, we're going to cross multiply. So first term we would get would be V0 times R1 plus R2. Again, that's just multiplying across this way. That should be equal to Vs R2. Again, that's multiplying across that way. So now when we have that, we should be able to multiply this out. So this would be equal to V0 times R1 plus V0 R2. Again, I just multiplied that through on this side. So now we want to get our R2s on the left-hand side. So then that would be R2 times Vs, which is that term. And then if we bring this term over, this term here over, subtracting, so it would be minus V0. R2's already been divided out. And then that's going to equal to V0 R1. So now solving for R2, we just divide both sides here by Vs, V0, Vs, V0. And that gives us the final result that we're looking for. R2 is equal to V0 R1 over Vs minus V0. So now that we have it in this form, we should be able to plug in our values. So in this case, using that equation, R2 is going to be equal to V0, which we said was 22 volts, and then R1 we said was 47 kiloohms. So remember, we have to do that times 1,000. And then that's divided by Vs, which is 200 volts, minus V out, which is 22. And when we plug all of that into our calculator, we should get something in the neighborhood of 5808.99, or some people may round that up then to 5809 ohms. So this is the value of the resistor for R2 in order to get that output voltage that we wanted. So now we need to determine what the power requirement at that resistor location would be. So then the power required at R2 then would just be equal to VR2 squared divided by R2. Okay, so the VR2 is just the output voltage, so the same thing as V out squared over R2. So if we plug those values in, that will be 22 squared divided by 5809. And when we plug that into the calculator, we should get 83.33 times 10 to the minus 3 watts, which is the same thing as 83.3 milliwatts, which in that case, that is less than 0.25 or a quarter watts. So therefore, a quarter watt rated resistor would work fine.